In this recording, we're going to learn how to divide polynomial expressions. And we're going to go back to numeric examples to kind of remember how we did long division back when we divided 7 into 1,519, things like that. So it turns out a division problem like 1519 divided by 7 could be written as a fraction. It could also be written as a long division. So let's review that process of the long division. We'll divide 7 into 1519. Okay, so if you remember, 7 can't go into 1, but it does go into 15 twice. So we write a 2 up on top. Then we multiply. Then we subtract. Then we bring down. Now we divide 7 into this 11. It goes in ones. Then we multiply. 1 times 7. Then we subtract. Crummy 7. That's really a 7 right there. Then we divide 7 into 49. It's 7. And then we multiply 49. And when we subtract, our remainder is 0. Nice. So in this case, there was no division. I'm sorry, there was no remainder. The question was, is there a remainder? There's not. So part B says, okay, rewrite this as a multiplication equation. So we can say 7 times 217 is equal to 1,519. Okay? The divisor, which is this called, times the quotient equals the dividend. Those are fancy mathy words. All right? Plus, I guess I should add in any remainder. We haven't seen that yet. All right, so come over here to part C. So we're going to divide 17 into 1522, same way. Okay, why don't you work this one out on your own and play the recording when you want help or you want to check your answer. Because hopefully you divided this out, and I'll just do the work. Okay, so I kind of ran out of space there, but I kind of got into problem D a little bit. That's okay. So it says write it as A plus remainder B, so I've done that on the top, 217 remainder 3, which kind of makes sense, right? Because 1522 is 3 past 1519. To express it in this form, A plus a fractional extra piece, we'll write it this way. It's 217 plus 3 whats. In this case, it's 3 sevenths. Okay, so it's an equivalent way to write it. And now this is where you're going to want to concentrate. Similarly to before, you're going to write 7 times 217. But of course, that's equal to 1519, right? So we have to add in an extra 3. So we have the divisor times the quotient plus any remainder. That's going to equal the dividend, 1522. Cool, so now let's deal with polynomials. Let's attack polynomials using that same approach. So I'll walk you through this. We're going to start out with the bottom number, the thing that's doing the division. That's the divisor. It's over on the left. And then the thing that's being divided, the numerator, called the dividend. It's underneath this division symbol. We're going to do a similar approach. We divide x into 2x squared. Notice I didn't even think about the 6. The 6 is going to kind of be there for the multiplication part. I'm looking at how many times does x go into 2x squared, and I write that on top. Okay, so that's going to be 2x. Now I'm going to multiply, like before, 2x times x plus 6. I'm going to distribute it. So 2x squared plus 12x. Okay? Now I'm going to use another color here because I'm going to subtract the binomial. Now when you subtract it, you got to subtract both terms. So I'm going to put a negative sign or a subtraction sign right next to both terms that I'm going to subtract. Now we subtract. That adds to 0. Subtract here, that's a 3x. And we bring down just like we brought down with the numerical long division. Okay, cool. So now I'm going to divide x into 3x. Don't even look at the 6, don't even look at the 18, just x into 3x. That's obviously 3. Write that on top. So now we multiply. 3 times x, 3 times 6. That goes underneath. And it turns out it's the same. So I'll use a different color here to show the subtraction. I'm going to subtract both terms. And it adds to 0. So that must mean it divides in evenly. So writing it in part B as an equivalent multiplication equation would be that x plus 6, the divisor, times the quotient, is equal to the dividend. Let me just get my square in here. I left my square out. Okay, so you can see that that's an equivalent expression. Now, let's attack part C. We're going to write this one. Now, this one's not going to divide in evenly, so we're going to have, like we did before with the 1522 back in the beginning, we're going to have a quotient, and then we're going to have the remainder, and that remainder is going to be a certain amount of x plus 6. And if you're saying, where's that coming from? Think back here. When we had a remainder, it was a remainder 3 out of 7, so we express it as 3/7. That's our remainder. Okay? Cool. So let's set this one up the same way. Let's see how far you can get on your own. We'll set it up. X plus 6 is our divisor. Our dividend is underneath. I'd like you to pause the recording, get as far as you can on your own, and then play when you need help. You want to check your answer. Okay, so hopefully you divided in x into 2x squared. Now I'm going to divide x into 3x. I'm just realizing I didn't write my x up here by the 2x. Let me get that. Sorry. 3 times this expression, x plus 6, write that underneath. Adds to 0, 2. We have a remainder of 2. Okay, so now we can express the original rational expression in this form. We've got a quotient. That's the number up on top, 2x plus 3. And then we've got our remainder, which is 2, over x plus 6, just like we had back in our original division up here on the top. We had our remainder, which is out of 7, 3/7. Okay. So, and this is also write it as an equivalent multiplication equation. So that would be okay, so let's unpack that a little bit. We've got our original dividend, part under the long division symbol, is equal to the divisor times the quotient plus 2. Okay? Plus 2. So if you were to distribute this, you would get what you have above. Now let's check that out. This is 18, and this is 20. So in order to make it equivalent, I have to add in that plus 2. That's where that 2 comes from. All right. At this point, you just need some reps. You need some practice dividing polynomials. As it says here at the top, it says when you divide 2 polynomials, you'll get another polynomial, plus potentially a remainder. And that's a rational expression, okay, written in quotient remainder form. Okay, so we've got our quotient, then whatever remainder we have divided by the divisor. So I'd like you to just work these out at your own pace. Play the recording when you want answers or want some help. Okay, so I'm just going to crank these out fast. You can slow it down or pause it as necessary. Now I'm looking to divide x into 5x. Okay, so I have a remainder here, and I'm going to write it in this form here. So I've got my original expression equals a quotient plus a remainder. Okay, so that's our answer to part A. Why don't you try part B? Play the recording when you're ready. Okay, so again, one more time, we're going to write our final answer. The original rational expression equals a quotient plus some fractional remainder. Thanks for watching.